to today's session. So we continue looking at the 2022 August Mathematics Past Paper 1. So this is the fourth part. So we are looking at question number 15. So in our today's episode, we'll focus on question 15, 16, and 17. So question 15 reads, a line passes through the points A, negative 2,5, and B, 0, y. Given that the gradient of AB is negative 3, find the coordinates of B. Find the coordinates of B. So what we need to know is, we need to understand what the gradient is. So the gradient basically is, we are talking about the slopeness of the line. So our slope with this line, so this change in y over change in x. So how do we find the change? So the change is, what you are saying is, if you started from point A, this is point A, then point B. What you are saying is, for us to move from here to A to B, we would have changed the direction. So there is a movement. Okay? So the movement in vertically and horizontally. So it's that change that we're interested in. So that change is what you're calling the gradient. So to find change, basically, the change is equal to, we call it M, is equal to the change in horizontal, which is y2, the new position, minus where we started from, y1, over x2, over x1. So this one is basically change. The y2 minus y1 is the change vertically in our elevation. Then x2 minus x1 is measuring the change horizontally, how we are moving in terms of flat. So in this case, B is our position 2, our final position, then A is our initial point. So the value of y at B is just basically y, then minus the value of y at A, our initial point, is basically 5, divided by the value of x at B is 0, minus the value of x at A is negative 2. Then this gradient itself we are given is what? A negative 3. So this must be equated to negative 3. Then this is over 1 basically. So it will be, simplifying, negative 3 over 1 equals y minus 5 is just y minus 5, because we don't know y. Then negative and negative is a positive. So it's basically from 0 we are moving backward. How many points? 2 points. So the difference is, our movement change is 2. Then at this point we can cross multiply. So it will be basically this one multiplied by this one, then this one multiplied by this one. So this is, we are multiplying it by 1, so nothing changes. So it will be 2 times negative 3 is negative 6, then equals basically y minus 5, because 1 times the whole thing here doesn't change anything, just itself. Then at this point we collect the like terms, so we have negative 6 plus 5, because when 5 crosses the equal sign, it becomes a positive. When any number crosses the equal sign, it changes the sign, so equals to y. So it will become now negative 6 plus positive 5, we get a negative 1 is equal to y. So the coordinates at B becomes 0, negative 1. So that's the answer to part A of our question 15. Let us move to question B quickly. So I can quickly lab on the board so that we have enough space. So B, in the diagram, ABC is a straight line. Angle BCD equals to 90. Then tan ABD equals negative 3 over 4. So this is our tan ABD. Then we know this is our 90. Okay, then the question is asking us calculate the length of BD. So for us to answer this question, we need to employ the principle SOHCAHTOA and Pythagoras theorem, where we are saying c square, which is the longest distance, is equal to a square plus b square. Okay, where this is hypotenuse, which is h here, then this is adjacent, which is a, then b will call it opposite. So that's what we need to know. So SOHCAHTOA, in the sense that we know that tan theta equals opposite over adjacent. Then, and this is this tan, which is opposite to the 90 degrees. So, and the angle on the other side of the tan, this angle. So, is this angle we are talking about is basically the opposite sign, the inverse of this angle. So what we are getting here, this angle here is what we are saying tan angle B. Okay, the angle at B. So it's this angle we are talking about. So if this is the case, what it means, the angle here is basically equal to tan. So the angle at CBD is equal to the opposite sign of this, which is 3/4. So that's the principle that we need to apply. So always that's the case. So given that, we know that tan any angle, which is in this case tan theta. So what is this? Theta is this angle CBD equals the opposite over adjacent, so which is the same as 3/4. So in this case, the length of opposite, so opposite in this case is equal to nothing but a 3. So opposite is equal to 3, then adjacent is equal to 4. So now given that, we can employ this equation. So c square, is the BD, which is c square. So BD square in this case equals opposite square plus adjacent square. So we have 3 square plus 4 square, which gives us basically 9 plus 16, which is equal to 25. So now we are looking for BD, where we know that BD square is equal to 25. So to find BD, we introduce the square root, both sides the square root. So BD equals 5. The square root of 25 is basically a 5. So we can't have a negative distance. So this is how you find this question. Okay, so this is question 15. Let us move quickly to question number 16. So question number 16 leads, basically we have two cylinders, A and B are geometrically similar, and the ratio of their heights is m/4 respectively. Given that the areas of A and B are 144 centimeters square and 256 centimeters square respectively, find the value of m. So the principle that we apply here is, if we have the ratio of the sides, okay, the sides, let us say sides of a shape, so two shapes, so their ratio is m to n of the length, okay, then the ratio of their area will square these sides, the ratio of their area. Then the ratio of their volume, because the volume is you're multiplying three things, so you cube volume. So basically this is the principle that we need to apply. So similarly, what we are saying, for us to find the ratio of their length, we need to square root so that we get back to this point. If it's volume, we're given the volume. For us to find the ratio of their sides or length, we cube root. So that is the principle we need to apply. So similarly, we have then in this case m over 4. Okay, then this is equal to the square roots of, because this is area of these individual areas, 1, 2, 5, 6. So what this tells us is m to 4 equals the square root of 144 is 12, the square root of 256 is 16. Then if you simplify here, we divide by 4, we get a 3, we divide by 4, we get a 4. So what you notice is a 4 and a 4, they are the same. So this 4 and this 4 are equal. So hence m should be equal to 3. So m should be basically equal to 3. So this is what you apply. Okay, that's question 16A. Let us move to question 16B. So 16B, the diagram below shows a square based right pyramid with an axis AB. Describe fully the symmetry of the pyramid. So if you notice the pyramid, when you're describing the symmetry of a pyramid or the symmetry of anything, we need to bring out two things out. The first thing is the center of rotation. So the center of rotation is basically along the x-axis. So what is the x-axis? Along this line. So it's at this x-axis. Thus the rotation. So rotation is at the axis. Number 2, we need to identify the order of rotation, okay, for us to maintain that symmetry. So the symmetry thing we are talking about, if I fold this, this line and this line should be identical so that it closes completely. So if I fold this one, this line should be identical to each other. So if I had a triangle, like the two-sided triangle, if I draw a line of symmetry there, this side and this side, they will be identical, so that when I fold, it closes equally. So similar in this case, we have, this is, since it's a square base pyramid, what it means is this side is equal to this side and this side and this side, and this, so four sides are the same. So what it means is this pyramid has 4 planes of symmetry. So 4 planes of symmetry. So we can fold this pyramid in 4 times and still maintain get the symmetry shape. So basically this is how you answer this question number 16. So let's move to our last question, question number 17. So question number 17 is on the leads. In the following diagram, A, B, C, and D are points on the circumference of the circle center, or BD is the diameter. So BD is the diameter, AD is equal to SC, and angle BDC is equal to 22. Then the question is asking us to find BAC, CBD, ACO, so those angles. So for us to quickly answer this question, let me just draw this one bigger quickly. So we have this circle, then we have these two are equal, then this is 22 degrees. Then from here we come here, then we join there, such that these two are equal. Great. So this is A, this is B, this is D, this is C. Then what you are told is to find BAC. BAC. So BAC, angle B. Sorry, I forgot to draw this line. So find angle BAC. So basically we are being asked to find this angle. Okay. So what we know is two angles as a circumference. So D and A, they are all the circumference. So these two angles should be equal. So this is basically 22 degrees also. So part A is 22 degrees. Okay. Then let us look at CBD. So angle CBD. Angle CBD. So it's basically this angle they're asking us to find. So we know this is 25. And we know that the angle, if this is passes through the center, so the opposite angle, so any triangle that has got a diameter, one of the sides is a diameter, then it touches the circle, this angle is always 90 degrees. So if it's 90 degrees, what we know is to find angle CBD, it will just be basically 180, the total angles in the triangle, minus 90 minus 22. So this is basically a 90 minus 22. So what we get basically is 68. So this is basically 68 degrees. So this is 68 degrees. Okay. Then we move to the last one, ACO. Angle ACO. Angle ACO. So it's basically this small angle that we are looking for. Okay. So how do you find the small angle? We know that if this is 22 and these are radius, then this also is 22. Okay. So now, if that's the case, and we know that this O angle is 90, so what we need to do is we need to find this angle. We need to find this angle before we do anything. So if that's the case, we know that these two sides are equal. These two sides are equal. We need to find this angle. Okay? And what we know is we have two angles at the circumference, this angle and this angle. So these two angles are equal, which is 68 also. Because this angle and this angle are two angles at the circumference. So two angles at the circumference are equal. They're starting from the same point D and C, then they're touching two circumference, so they are equal. So if you know that angle, we can easily find the angles, this angle, the total angle, then you can find, because these two sides are equal, so it will just be 180 minus 68, which will give us basically 112. We divide by 2, so we get 56. So this entire angle here is 56. So 56, we take out 22. So 56 minus 22, we get 34 degrees. So this angle here, which is this one, is 34 degrees. So this angle is 34, then this angle is 22. So this is 34, this is 68. So basically this is how you answer this kind of a question. So these are the principles that you can answer, or you can use to answer all the questions. So you can even proceed to answer this question. We know that the angle at the center is twice the angle at the circumference, so this is 44. We can answer other angles in case we are asked. Then the straight line is 180. 180 minus 44 will remain with 136. So this is 136. So if you know 136, you know that the angles at the center is twice the angle of the circumference. So this one is twice that one. Collect. Then after finding this is 44, then this is 34. 34 plus 44 you get 878. So what you discover is from 100 we take out, from 180 we take out 78, will remain with 102. So this angle is 102, and this angle should also be 102. Then this angle will be 78, then this angle will be 78. So this is how you can answer all the angles in the shortest possible period. And we know that if this angle 34, this angle is 56, then this angle is also 56. So this is how you answer all the questions. So for today, we end here. Then we'll pick it up from question 18, 19, and 20 in the next session. Thank you very much.